My name is Trent. I'll be the chair for the session on official statistics. Our first abstract is from Matthew Zhu from Christchurch, and his talk's on modelling detailed food and non-alcoholic beverages expenditures, investigating possible methodologies for future expenditure surveys. And Matthew, whenever you're ready, you can go.
Yep. So good afternoon. Today I'll be talking about a project I worked on with my colleagues Franklin Soriano and Anderson Yang. It's about investigating a new methodology for future household expenditure surveys and modeling detailed food and non-alcoholic beverages expenditures. Okay, so for a bit of background, household expenditure surveys provide a lot of valuable microdata for estimating spending patterns and weighting of the consumer price index, and also producing key indicators of Australia's living standards and economic well-being. There is an issue, however. These surveys are often quite burdensome, requiring detailed expenditure diaries, and that's something that at the ABS we're trying to reduce. So this slide shows a comparison of the designs of previous surveys and the potential design of future surveys. So one thing to note is that household expenditure surveys are often conducted with the same households in conjunction with surveys of income and housing. So those are the rows shown in orange there, and that's quite important because it allows us to kind of map relationships between income and housing variables and household expenditure. But on the left there, under the orange rows, we have the household expenditure data. You can see the green rows are 4-digit food groups. So there's bakery products and flours and cereals. There's also meat. And then under those green rows, there's blue rows. So under meat, for instance, there's chicken. There would also be other meats like pork and beef under there. On the right, however, a possibility for future surveys is that those 8-digit food groups will be removed from the survey. So we're looking for ways to model that in their absence. So this is a quick overview of the methodology I'm going to be talking about. So SCI on the left there in the orange stands for Survey of Income and Housing, and HES for clarity stands for Household Expenditure Survey. So we use predictive factors from the SCI to we look at the SCI data and we use it to find predictive factors for HES data. So we're looking at what's the relationship between income and housing variables and household expenditure. So we're looking at historic data to do that. We then are going to fit those relationships to new survey data in order to produce our modeled 8-digit microdata, 8-digit being those green rows from the earlier slide. So into the methodology to achieve this, the first step is just quite a simple one. We're going to transform the native data from those surveys in order to create unit level variables appropriate for our coding and our modeling. The next step is we're going to perform logistic regressions on the historical data sets to find how those SCI and HES variables predict whether a household will consume or not consume a given 8-digit food group. So we quickly realized that relying on standard linear regression models wouldn't quite work for this kind of modeling. That's because there's over 80 food items in the HES, and doing linear regression would, at its most basic level, is essentially predict expected values of expenditure. And that's going to be non-zero for all of these items, and that's not really a realistic picture of a household's consumption patterns over a survey period. And so at the bottom, we have an example of the logistic regressions used. So this is for the 8-digit food of butter. So we have the probability of consuming butter regressed on disposable income, wealth, dummy variables for family composition. We also include a variable from the same household expenditure survey itself. Instead of the survey of income and housing, that's a level of dairy consumption. So dairy is the 4-digit parent food group. Now remember, we still have that information, and that is actually quite an important regressor. The next step is we're going to deflate household income, wealth, and those household expenditure data variables for the new data, new households where necessary to improve the applicability of the relationships in the historic data. So for instance, consider that if you have a household with certain characteristics, let's say $100,000 of income and a certain level of wealth, and we predict a probability for how likely that household is to consume beef, given those characteristics, that probability wouldn't be as true for newer data, since it's based on old information, since the price of beef has gone up. So if the price of beef has gone up a lot, the same level of income isn't going to, the same household should probably have a lower probability of consuming beef since the price has gone up. So we essentially deflate those variables by the CPI change. Unfortunately, we couldn't do it at the eight-digit group. If we wanted to look at beef, we would have deflated at the 4-digit meat level. So this is where it gets a bit more interesting. So the next step is we then fit those logistic regression coefficients to our now deflated household values from the new data, and we basically give all these households a model probability of consuming goods at the 8-digit level. And now using those model probabilities, we perform Monte Carlo simulations, also known as Bernoulli random variable simulations. And we do these for each household, for each 8-digit food good, and we essentially predict whether or not a household consumed or did not consume each food with the simulation. Now, sometimes these simulations may actually result in a contradiction. So for instance, if we see in the survey data that a household, I'm going to use the meat example again, if a household has a non-zero level of meat expenditure, but our simulations show result in an outcome where they actually had zero expenditure for each 8-digit meat, so like chicken and pork, then we actually will rerun the simulations again until that contradiction no longer happens. So at least one of those 8-digit food goods has to be non-zero. So we back-tested this methodology on previous surveys. So we used 2009-10 Tsai and Hess data to predict the expenditure in 2015-16, which we then compared to the actual surveyed 8-digit consumption in 15-16. We computed something that we called match rates. These essentially show the proportion of households for which we correctly predicted whether or not they did or did not consume an 8-digit good. So on the right there, those are the match rates of our methodology, and on the left, we have a naive approach that doesn't use those survey of income and housing variables as predictors. So by and large, our methodology shows significant improvements on that naive approach. Okay, next Next, I'm going to talk about our next set of regressions. So now, instead of looking at computing the probability of consuming a good, on historical data, on those households that had non-zero expenditure in a given 8-digit good, we perform linear regressions this time to find how those household characteristics predict this time the level of food consumption as opposed to the probability of food consumption. So the example given there, it's for the same good of butter, except this time the dependent variable is the level of butter consumption as opposed to the probability. And then the step after that is, once again, like before, we fit those linear regression coefficients from the historical data to the newer survey data to predict their levels of 8-digit expenditure. The final step is a standardization process. Essentially, the sum of our estimated 8-digit expenditures is unlikely to exactly add up to the surveyed 4-digit expenditure. So if, for example, we predict that the sum of the 8-digit expenditures under, the dairy food group add up to $55, but then we have actual survey data of $50. We just take a simple multiplication of 50 over 55 for all of those food groups, and we get that standardized number. And that's our final simulated microdata output. So back on our the back testing of the methodology, this is a table. On the left there, we have, so this focuses solely on the 4-digit bakery, flour, and grains food group, I think. So we have the items on the left there, and on the top, we're basically showing the differences between our modeled proportions and our surveyed and the actual true survey proportions in the back testing, and the blue columns are the differences. So while it's not a perfect methodology, I think the results are promising, and I think it points to the viability for this methodology in the future should the surveys actually lose that information. We're also looking at supplementing this approach with potentially looking at scanner data in order to have more up-to-date information, and also, if possible, getting access to rewards cards data, which actually has a really good link between households and consumption. All right, thank you, everyone.
Thank you, Matthew. That was really interesting. Up next is Muskan in Christchurch as well. And she's talking about managing workload challenges in household surveys, strategies for effective PSU reformation and overlap control. Whenever you're ready.
So this is Muskan representing Stats New Zealand, and my topic is managing workload challenges in household surveys, so which is basically around HLFS, my prime work. And HLFS is Household Labour Force Survey, which is a quarterly survey that we conduct here in New Zealand, and it provides us with key labour market statistics such as employment rate, unemployment rate, and labour force participation rate. And to sample households, we use primary sampling units known as PSUs. So they are basically geographic areas that we consider as sampling units for the survey, and on average, it contains 70 to 80 dwellings. And once we have got the geographic areas PSU sorted, we classify them into different strata based on different demographics that we need for the survey. And from each strata, we select PSUs. However, at this stage, the random selection is controlled by overlap control methodology, which basically means we try avoiding going to the same PSUs that have been used for different surveys in the recent past. And once we have selected the PSU, we divide them into panels and select one of the panels from them. So panels are basically, we divide the PSU into subgroups of equal sizes. And it's basically in a systematic fashion, like 1 to 3, 1 to 3, and so on. So if you look at the picture here, I have used the color code. So it's yellow, pink, blue, green, peach, and white. And it continues like this. So all the yellow ones consider the panel 1, and the pink ones are panel 2, and so on. So basically, what's the benefit of this one is we can use the same PSU for multiple surveys, choosing different panel each time, or we can use the same PSU for the same survey at different times using a different panel number each time. So it helps us with that. And now the problem that we encountered was we do periodic enumeration in HLFS, and to maintain the dwelling list so that it's accurate. And with the large population growth, as we are aware of in New Zealand, we had increased number of dwellings in the PSUs, and which impacts the representativeness of the sample. So if you look at the graph on the left, which says 2018, so it's a region which had all the enumeration in one corner, leaving the rest of the paddocks and fields. So that area was not used at all. And by 2023, you can see the streets and the houses and the development up there. So this led to problem with HLFS. And we had some operational challenges, which was increased workload for collections and increased costs associated with it. Plus, it also affects our outputs with increasing variance because our sample is too big. Collections cannot go to each household in the sample. So it increases the non-response and also reduce precision of our labor market estimates. So while we were managing this problem, we had few factors that we considered. So it's feasibility of household service, making sure that we have manageable workload, and plus that this feasible collection will reduce the non-response, especially because of collection people are not being able to cover all of the selected households. So that solves that problem. Plus, the next thing is we preserve the PSU integrity. So here is the term PSU reformation. So what happens is after every census, we have a new list of dwellings. So we look at the PSUs, which have really large growth in the size, and we split them into smaller PSUs with an average of 70 to 80 dwellings. And we have used a strategy here so that we can make sure all the new dwellings that we have in that specific PSU form the new PSU. So the new development goes in the new PSUs that we will do after every census. And the third aspect that we considered was we wanted to have minimal changes in the selection weight so that our outputs are not affected adversely. And the new developments that we might ignore in this case are still incorporated in our outputs using the benchmarking. So what we did was, I'll start with the case study. So assumingly we had a PSU which had grown by 652 dwellings. So there were 70 addresses in there and now 722. So when there were 70 addresses, we give them a systematic enumeration, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. We got 7 panels, each with 10 dwellings. And then we calculated the household selection weight, which is like number of dwellings in the PSU divided by maximum dwellings in the panel, which is 10. So we got 7. Now, if we do not do anything now and automatic repaneling happens, all the new households will get the panel number 1 to 7, and we have over 100 dwellings in each panel, which is problematic for collections. So we have drafted the solution. So as we have looked up there, all the old enumeration was in one corner of the PSU. So we looked at the cases, all the cases we had either of these situations. The new houses constructed are all outside of their region, or there are some new development in that old region as well. So if the case when we have no new house in the old enumeration corner, we did not change anything. We, for that finite period of time, assumed that the new houses do not exist for that specific PSU. And although those new houses were still being included in the outputs using benchmarking at the end. And this is for a finite period of time, because after every census, we still do PSU reformation when these houses are taken into account again. And when we have some new houses in that old corner, we do something called reallocation of panels. And having a look at the graph here, so the pink area is where we have the old dwellings. And in this case, some new dwellings as well. And the yellow is one where we only have the new dwellings. So the pink corner has 70 old dwellings with 7 panels. And so we do the same thing for the 63 new dwellings in that corner. So again, 1, 2, 3, 4, 5, 6, 7. So we got 9 more dwellings in each panel, a total of 19 dwellings now in the specific pink corner. And the rest of the new dwellings in yellow corner will get panel numbers from 8 onwards. And we still make sure that the panel size is same. They are also having 19 dwellings each. We have a consideration that we can have a difference of 1 in the panel size. So we can have a situation where most of the panels have 19 dwellings, but one has 20 or 18. That's acceptable in these cases. So when we did that, we had seen in first case, if we do automatic repaneling, the workload was over 100. Now it's just 19, increased by 9 only. Collections is happy with this. And now we have panels from 8 to 38 that we are not going to touch at all for the specific finite period of time. So when we do PSU reformation, those panels will be split into new PSUs that we can be used for further surveys, and they are like untouched, fresh, and they are available for a future sample selection. And in this case, we have altered a bit for the household selection weight. Rather than selecting total dwellings in the PSU, we are restricting it to the area we selected, to the pink corner of the PSU. So our household selection weight almost remains same, doesn't affect much of our outputs. And the reason for this is because it truly calculates the probability of selecting a dwelling, because each of these houses are in one of the 7 panels, and each panel has 1/7 probability of being selected. So that sounds fair enough for us. And still, if we are concerned about the houses that we have ignored in this case are still being considered while we are doing benchmarking. And again, I'll repeat, this is just for a finite period of time, because those houses will be reconsidered while we do PSU reformation. So I'll just wrap it up here, going back again to the problem. With enumeration, we had increase in size, which was problem for workload for collections and the cost, and also affect the accuracy of our estimates. And so for solution, we just looked at our area as like having old enumeration and a new enumeration corner. So if the old enumeration corner does not have any new development, we do nothing. And if it has some new development, we do repaneling for those new houses in that specific area only. And while making sure that the new houses still are available for future PSU selection when we do PSU reformation. And I'll reiterate, that this is just for a finite period of time. And I think that's the end of my talk. Thank you.
Thanks very much, Muskan. That was really interesting. Next up is in Perth, we have Min Han Ho talking about Singapore's second national suicide survey.
Thanks, Fred. Is that presenter view available? Sorry, is that presenter view available, please?
You want the video?
The presenter view.
Oh, yes, yes.
It's okay. I can just use my.
I think it's going to show up on there.
Yeah.
That's the problem. Alright.
Hello. Okay, good afternoon, everyone. My name is Minhan, and I'm a student from Singapore Management University. I've come all the way here. So, in 2022, Singapore faced its highest suicide rate in 2 decades that ignited critical discussions regarding suicide prevention in Singapore. And now, while most of the existing research has largely focused on the psychological or biological factors regarding suicide, there has been limited exploration into our cultural, environmental, and societal influences, especially in a city context like Singapore. So this gap led to Singapore's first nationwide suicide survey in Singapore titled Save Me, that was done by Singapore Management University in collaboration with the Samaritans of Singapore to examine Singaporeans' attitudes and knowledge about suicide. So when my statistics professor, Ms. Woody Cheng, introduced the follow-up project, Save Me 2, I initially felt, out of my depth, like I am here today, because I was wondering, can I, a freshman, truly contribute to a national level change? But as I got more involved, I realized that every effort, no matter how big or small, counted in the fight against suicide. Thus, this February this year, my classmates and I set out to survey over 5,200 people across Singapore. Our goal was not only to collect data, but also to understand the lived experiences of our community. And some of the pictures you see here are some of my interactions with members of the public. And I was quite surprised at, how during these interviews, at how open residents are actually to having a genuine conversation with you regarding suicide if you initiate the topic with them. Especially that this was also during the Lunar New Year period, where talking about such things could be considered taboo and quite inauspicious. So after conversing with and interviewing multiple individuals around Singapore, what we discovered painted a powerful picture of our society's relationship with suicide. Our first question was, how much do Singaporeans know about suicide? And to explore this, we asked respondents about common myths. Shockingly, 64% believe that discussing suicide could give someone the idea to attempt it. And 56% thought that 56% thought that most suicides happen without warning. These beliefs not only reflect the persistent misconceptions in our society, but also a hesitation to approach this topic directly. Most respondents attributed their lack of knowledge to limited outreach or education on the topic. Yet, despite having limited knowledge, 9 in 10 believe that suicide is preventable, and over half of them thought that it was even predictable. So this gap between hope and action was a powerful theme in our findings. On one hand, respondents were confident in the steps that they would take to support someone with suicidal thoughts. But when it came to actually doing it, over 1 in 3 said that they would act without hesitation. And for the other 68%, their reasons for inaction echoed this realization that we kept returning to, which was that Singaporeans know what to do to help, but they don't know how to do it. So what can Singapore do then to support those affected by suicide? To answer this, we analyzed preferences for both giving and receiving support. And what we found was that while many prefer to share their problems face-to-face with a friend or close family member, they also expressed a strong desire for anonymity, which revealed a contradiction that was deeply rooted in stigma and a reluctance to speak openly. Among those wanting to help, a majority felt that national suicide prevention efforts could be significantly improved, underscoring a need for a national strategy. So at the beginning of this presentation, I mentioned about the shortage of research on the cultural and societal front. And the reason for this is also a very common problem in social science, which is that qualitative data, is incredible at providing rich insights and delve into the feelings of respondents, but it also lacks the ability to identify trends that is necessary for scalable strategies, especially at the governmental level. So this led to the creation of the Suicide Stigma Index, the SSI for short, which is a quantitative metric measuring social stigma around suicide in Singapore. By quantifying respondents' knowledge and perceptions into a score from 0 being the least stigmatic to 100 being the most stigmatic, we are able to map stigma across demographics, find relationships, as well as do time series analysis. And the results were striking. We found that stigma varied significantly across religion, race, gender, as well as age, with the demographic of under 21, the demographic most disproportionately affected by suicide, also holding the highest levels of stigma. So it's obvious, right, that something needs to be done about this, and soon. But despite this urgency, we saw no significant improvement in Singapore's overall stigma score since our first project in 2022. So this stagnation fueled our determination to make an impact. What did we do? We organized an exhibition where we transformed our findings into visual narratives that engaged participants on a personal level. We displayed heartfelt quotes from survey respondents, and we even simulated the losing of a loved one to suicide and the impact it has on family and friends. The people closest to the victim who, once again, knew what to do, but did not know how to reach out to help. These stories resonated with our visitors, sparking conversations and encouraging open dialogue about mental health, something that was often avoided in Asian societies like Singapore. Many attendees also expressed their gratitude for this opportunity to discuss this often taboo topic. The culmination of our project was a grand finale, where we showcased our findings and emphasized the importance of open dialogue about suicide in our very own special way. There were some startling, wrenching personal stories shared that humanized the statistics and beyond numbers and charts, and really connected us all as one class. Furthermore, following on Australia's very own national suicide prevention strategy, the insights from Save Me Too also helped shape Singapore's first ever national suicide prevention project, named Hayat, that was launched this very September. The term Hayat, which means life in Singapore's national language, Malay, brought together leading mental health advocates all around Singapore to drive a united front towards governmental action on suicide prevention. Now, reflecting on this journey, it becomes increasingly clear that addressing suicide is a communal responsibility. Each of us have a role to play in fostering understanding, compassion, and support. The insights from Save Me Too here underscore the urgent need for educational initiatives that empower individuals to act when someone reaches out for help. We must foster open dialogues about mental health, dismantle the stigma around suicide, and encourage people to seek help without fear. Finally, all these findings from Save Me Too are rooted in Singapore's context, but this message extends far beyond the realms of Singapore or suicide. If anything, what I hope you take away is the potential for education to make social change. Because think about it, a group of freshmen, undergraduates, people who were, encountering statistics for the first time in their life, were able to make an impact on a national level, highlighting that sometimes addressing social issues doesn't always require expertise, but effort and opportunity. So imagine what we could achieve if we redesigned our educational systems to create more of these opportunities. Rather than focusing on assessments or grades, we could provide avenues for students to apply their learning to the challenges faced in their community. This approach can not only encourage students, engage students more deeply, but also empower them to contribute meaningfully to their society. For after all, Save Me Too was more than just a class to me. It was an opportunity to see how the skills I've developed in school could bring change to the real world. So I hope by sharing this experience, I have encouraged you to think about how we could equip future generations to do the same. Thank you.
That was really good, Min. I've got one question for you straight away. Do you get any traction with the government, or do you plan to push your research towards them to see if they make any change?
Thank you. So traction from the government-wise, we have invited local government ministers, one of which was the Senior Parliamentary Secretary of Singapore, Mr. Eric Chua, to engage with and participate in our exhibition. And furthermore, as mentioned, we have had some impact in driving our national suicide prevention strategy. So following this September's release of the white paper, we are hoping that the government would definitely do something with it in the next couple of years. Yeah.
Cool. Do we have any questions in Perth for any of our speakers?
Thanks, Minhan. That was a great presentation. Have you looked at the suicide stigma index and compared it across different countries, or do you have any, have you come across it in your research as to whether or not there's variabilities between different countries or different cultures and how that compares?
Thank you. Great question. So the first thing to note is that the suicide stigma index is something that we've created ourselves in Singapore Management University. So I've not really looked into whether there has been relevant or similar metrics done by studies in other countries, but that is something that would definitely be able to look into so that we can, compare ourselves against other countries and kind of force the government to make a change.
Is there any other questions in Christchurch or Hobart? Okay, there's none online at the moment. I've got a question for Matthew. Out of the food groups you looked at, were there any surprising consumption rates or prices over time, ones that really stood out?
Oh, I'm having a think right now. Actually, we did another project after this that looked at scanner data, and that one had more kind of interesting relationships. But this one was essentially looking at existing, because we don't have the new data, right? This is a proposed methodology for the future. So essentially, if we find anything interesting, it would be things that aren't necessarily from our research. It's just from the existing household expenditure surveys already. So those things are already publicly published. So it's not really the scope of this particular project. But yeah, in a following project, we looked at scanner data and we tried to map that to socioeconomics at a suburb level. And there were some interesting things. We found interesting effects between income and like substitute goods. There's a clear effect with like fresh vegetables and frozen vegetables, for instance, or fresh seafood and frozen seafood. Yeah, this is like has the typical substitution effect where lower income might consume the the inferior good but still good substitute in the frozen equivalent, if that makes sense. Thanks
Yeah,
for the
cool.
question.
I have a question for Minhan. Just about you mentioned tracking it over time. Is there a plan to collect more data once the strategy, the white paper is out and the strategy is in place?
Yeah, so to answer the question, great question, by the way. We have had regular iterations of our projects. So this is the second iteration of Save Me, and we are hoping that this would be a prolonged effort. The thing is that these projects are typically done in our statistics class in Singapore Management University. So it is up to maybe the professor in charge, Ms. Rosie Cheng, whether she wants to continue Save Me Too for the next few years. But on that aside, we have had other projects relating to other social causes. So our most recent, this semester actually, our project was on public cleanliness, public hygiene, and that was in our 4th year running. So this was since 2016, and we were able to do time series analysis for 4 years worth of data. Yeah.
Great, thank you.